Hey everyone, I welcome you all to CMA FINAL SCN series. Yes, you might have seen it from the thumbnail only. We are going to solve the simplex method in this video. Now, 2-3 pointers before I go ahead. Yes, the name is simplex method, but it is not that simple. It is complicated. A lot of students practice this, a lot of students try to understand this, but when this question comes in the examination, people try to leave it because they feel that they will go wrong somewhere. So there are a lot of calculations in this, and it's a bit mechanical also. So this is number one. Number two, you might have done simplex up till now, exams around the corner, but if you need in a very simple language, very simple method, and if you do not want to leave it in the examination, watch this video. Okay. Number three, whenever I am writing, obviously you need to solve it with me. I'm going to solve the entire question. It's not printed or PDF something, it's just a question. So please solve it with me. If you understand one question also very properly, you might be able to solve a lot of questions of simplex, okay, if it comes to the examination. Now, the most important point before I start with the simplex method is that if you have watched LPP lectures, the linear programming problem lecture, then only come to this. Simplex is a part of linear programming problem. So if you are in such a position right now where you can formulate equation, which is very simple, you need to understand the question, you need to set the maximize objective function or the minimize whatever it might be, constraint to with limitations. Now, if you're able to do that, then your journey with simplex starts. So if you have not watched, if you have not understood how to formulate, please go and do that and then come to this lecture. The most important part. Now, before I start with simplex, pay attention please. Simplex method is used where there are three decision variables. Where there are three decision variables. Where there are three decision variables. Everyone pay attention very properly. My job is to tell you simplex in the most simple manner. Okay, you need to pay attention. Okay, for three decision variables, we will use simplex. Okay, so why not? Why can't we use the normal graphical method? Absolutely not, because it doesn't make any sense. There are only two vertical lines. Okay, it's x and y. So for two decision variables, I'm talking decision, right? Okay, two decision variable, we will use the graphical method. We'll use the graphical method, which I think they will not ask you because it's all formulation. Okay, you can do one sum of graphical method, but understand the formulation of the equation. That is much more important than going to graphical method. But simplex, yes, they will ask you simplex. Okay, now, so this is the main ABCDs of simplex. I'll repeat it once again. If at all there is a big banner in your question, please kindly use simplex method. Then you don't have any other option, you have to do that only, because it's very simple. They've written the simplex method to solve. But if this is a normal question and they've written at the end, formulate this by your LPP, first of all you need to check over there whether there are two decision variables or three decisions. So they will not write there use simplex. If it is three decision, you will compulsory have to use what? Simplex method only. You do understand this? Simple. Okay, now there's a question in front of you. First, we'll formulate the equation and then I will go to the simplex problem, the simplex method. Okay, everyone ready? Understand one question very carefully, like very properly. Even if you have time after watching this video, you can copy down the question and you can do it by your own self. Okay, sure. Can you start with this question, ladies and gentlemen? Sure. A company has three operational departments: weaving, processing, and packing, with capacity to produce three different types of clothes, namely suiting, shirting, and woolens. So they have three final products, that is the suiting, shirting, and woolen. And for that, three departments have been used in this own factory: the weaving department, the processing department, and the packing department. Okay, yielding a profit of 2, 4, and 3 respectively. So basically, when you will make, the students who have bought my fast track or the regular series, you might have understood by one thing by now, because the first thing what we do is that it is maximize objective function. You need to understand where the question is going. Now it is clear cut over here, they're talking about profit, so they're talking about maximizing the profit. Okay, now whenever I have told you this, that before like reading the question, the first thing you need to do is that you need to put it up in a tabular format. See, this is all paragraph wise. It becomes very impossible for you to solve it. So the best thing is what? Put it in a tabular format. It becomes very easy for you to bring up the equations in the answer sheet. Okay, we'll do that in a minute. First, we'll complete the question. Next, 1 meter suiting requires 3 minutes in weaving, 2 minutes in processing, and 1 minute in packing. So your columns has to be like this: suiting, shirting, and what is that? Woolen. And you have weaving, processing, and packing departments. Then the numbers will come, whatever they have mentioned over here. Similarly, 1 meter requires 4 minutes, 1 minute, and 3 minutes respectively. And 1 meter woolen requires the 3 meters in each department. Okay. In a week, total runtime of each department is 60, 40, and 80 hours of weaving, processing, and packing. Formulate the linear programming problem and find the product mix to maximize the profit. Now, in the entire question, there is not a single mention of Simplex. Now, you need to understand one thing. There are 3 decision variables, X, Y, and Z. If there are 3 decision variables, we need to use compulsory Simplex method, but we cannot do it by graphical method. Okay, chalo. Can we solve by doing the key data first and then I'll go to the Simplex. Okay, so pay attention everybody please. Solution. First we'll write down the key data. First we'll write down the key data. I've already told you, please make columns. Okay, very simple. So 3 departments are there and 3 product clothes are there. Suiting, shirting, and woolen. So I'll write here suiting, shirting, and woolen. And you have 3 departments. What is that? Weaving, processing, and packing. Weaving, processing, and packing. Now, if you do this, it becomes very simple. You have to just put the figures now. Okay, that's it. See, 1 meter suiting requires 3 minutes in weaving, 2 minutes in processing, and 1 minute in packing. So 3, 2, and 1. 1 sec. 3 minutes in weaving, 3 minutes in weaving, 2 minutes in processing, and 1 minute in packing. Then we go to shirting. Similarly, 1 meter of shirting requires 4 minutes in weaving, 4 minutes in weaving, 1 minute in processing, and 3 minutes in packing. The last is woolen, 3 minutes in each. So 3, 3, and 3. Okay, that's it. 90% of your work is done here only, of formulation, okay, not Simplex. Now, next, the total runtime of each department is 60, 40, and 80. Can I say this is the limitation constraint? Because whatever you do, this is the limit. Now, 60. Now, see, the main point in this is, so if you're not paying proper attention to the examination, you might end up going wrong over here. You know why? Because, see, all the information above is given for minutes. Whenever I'm dictating, I'm reading minutes over there. They're given minutes, right? But here they've given what hour. So it's very simple. We need to complete this in minutes so that it becomes at par. Okay, all the information. So 60 hours. So what we'll do is 60 hours into 60 minutes, it will become 3600 minutes. So can I write one thing over here? Maximum available time. Maximum, because you cannot go beyond this, right? The first one will be 3600. What is second? 40 into 60. This will be 2400. This will be 2400. Last is what? 80 into 60. And this is 4800. Now, this is your proper table. If missed out one thing, write it down, and that is your profit. How much is profit? They have told you already. Is 2, 4, and 3. 2, 4, and 3. So, ladies and gentlemen, this is your basically what? Your table. Okay. Now, can we start making the equation first and then we go on to Simplex method? Okay. So, first we'll write let the company produce. Let the company produce X meters of suiting, X meter of suiting, Y meter of shirting, Y meter of shirting, and Z meter of woolen. Okay. Now, after this, we'll try to make the objective function. So objective function is maximize z is equal to 2x plus 4y plus what is that? 3z. Okay. So this is the profit what you will get, but this has limitations. That's it. That is what we call as constraint 2. So what do you write over here? Constraint 2. So this is a limitation. So 3x plus 4y plus 3z is less than or equal to 3600. So you cannot go more than 3600. That's the maximum time available. So what I'll write over here? 3x plus 4y plus what is this? 3z. One sec. 3z is less than or equal to 3600. We'll make a common this narration over there, because the three constraint will have a common narration only. That is the maximum time available. Okay. Next, this is x plus 2x. My bad. 2x plus y plus 3z must be less than or equal to 2400. And last is x plus 3y plus 3z must be less than or equal to 4800. Finish. Okay. Maximum time availability constraint. Okay. Now my answer would have been finished here only if these guys would have asked me only formulation of what this. They've asked us more also. They've asked us what? To find the product mix to maximize the profit. Okay. So what I feel is in the examination they will give you very clear-cut instructions that you please solve by simplex method. Okay. So as there are three decision variables, we need to solve this by simplex. Now here starts the simplex process. Okay. Now I want everybody to please pay attention and understand the format and how to compute that thing. Okay, it's very simple. Sure. First thing we'll write here, as there are three decision variables, we will solve this problem. By simplex. So now we will proceed towards the simplex method. Now understand this very carefully. First, we need to formulate under simplex method. We've already formulated. Now this was under normal. Now we need to bring it under simplex. And next, the most important part, that is the simplex table. Okay. But first thing what we'll do is formulation under simplex method. Now everybody please pay attention. Under this method, we use certain variables called as slack variables, SLACK. We use this slack variables. Now, and this is denoted by the letter S. Now, this being three decision variables, we need to add three slack variables to it. S1, S2 and S3. So, a simple start will be to copy down the objective function plus add these variables. How will we do it? This is there in front of you, the maximization function, that is 2x plus 4y plus 3z. Z is equal to 2x plus 4y plus 3z. Now plus add the three variables with zero number. 0s1 plus 0s2 plus 0s3. Now this is constrained to the limitations, the constraint which you have already done it, okay, which is this 1, 2 and 3. You have to add like this, but this time we will not add the sign less than or equal to. We will add equal to. We want two equations, left hand side and right hand side. So it's very simple. 3x plus 4y plus 3z. Don't forget to add the variables. Okay, so how will we do it? Constraint to 3x plus 4y plus 3z plus. Now we need to start adding the variables in such a manner that in one line, in one equation, at least one number is there. Okay, so how? So 1, so it will be s1 plus 0s2 plus 0s3 is equal to, what is the number? Right hand side, 3600. 3600. Same thing you have to follow for next equation also. How will you do it? Copy it on the same thing. 2x plus y plus 3z. 2x plus y plus 3z plus 0s1 plus s2 plus 0s3 is equal to, what is the number? 2400. 2400. We have to make a pattern. So s1 will be up, s2 and s3 will be down. Last, x plus 3y, x plus 3y plus 3z plus 0s1 plus 0s2 plus s3 is equal to 4800. That's a right hand side equation. Now see, observe two things. This has changed. This is equal to an s1, s2 and s3. So this is your first step of your simplex. Simple. Now the most important, I have drawn a format of the simplex table, but I have not put the figures. We solve it. Okay, let me just first of all explain you the format which I need you everybody to write down in your table. Okay, in your book. Okay, the first thing starts with this thing called as CJ. Okay, that's the coefficient number. So what is the coefficient number? Same, it was there in your maximization. So for example, this 2, 4, 3, 0, 0 and 0. That's what we have written over here. 2, 4, 3, 0, 0 and 0. That's the first row. In the second, one sec. In the second, we start with something called as CSV. So full form, current solution variable. Current solution variable. And adjacent to it, it is something called as CV, called as coefficient of CSV. So the example is, if CSV is over here, the three variables will come over there, S1, S2 and S3. And what were the coefficient used over there? So it was 0, 0 and 0. Very simple. Now, next, we'll write down the numbers. Okay, now what are the numbers we used over here? 3, 4, 3. 3, 4, 3. Next, 1, 0, 0. 1, 0, 0. Next, 2, 1, 3. 2, 1, 3. Next, 0, 1, 0. 0, 1, 0. Last, 1, 3, 3. 1, 3, 3 and 0, 0, 1. The B stands for right hand side of the equation set, those numbers. And R stands for replacement ratio, which I tell you how to compute, which is to be done in the end. Now everyone pay attention, okay? Then pause the video, you can draw the columns till I wait. Okay, so now, sir, B, what is B over here? 3600, 4800 and 2400, right? Sorry, 2400 and 4800. 2400 and 4800. Okay, that's the B, that's the right hand side of the equation. Now your game starts from here. Everybody pay attention, please. First thing, very simple. We need to compute something called as ZJ. It's there in front of you, ZJ. So how to compute ZJ? So this into 0 plus this into 0 plus this into 0. So one column into your CB. So how will you do it? Sir, anything multiplied by 0, you added, you multiply, it will become 0 only. So yes, that's the part. It becomes 0, 0, 0, 0, 0 and 0. The main point is to compute something called as NER. After computation of this, then you'll understand whether this solution is optimal or not. And I'll tell you also how to do it. So how to compute NER? Very simple. ZJ minus CJ. ZJ is over here and CJ is over here. So we need to compute two things. This is ZJ and this is CJ. Please subtract and see what's the number. So 0 minus 2, minus 2, 0 minus 4, minus 4, 0 minus 3 minus 3, it's a 0, 0 and 0. Now pay attention please. The moment this is done, everything, we need to find out what is the entering variable and what is the leaving variable. Okay, the entering variable, the rule is find out the least number from Zj minus Cj, that is NER. The least number is this minus 4. This is called as the entering variable. Don't write this in the examination. Entering variable, this is only for your understanding. Entering variable. Okay, the moment that column is fixed, that column is fixed, the y column. Okay, now you need to come down to that RR part. If this is fixed, this means what? These three numbers are fixed. So now we need to compute this. How will we compute? 3600 divided by 4, 2400 divided by what is that, 1, and 4800 divided by what is this, 3. What is this? So this will be 900, this will be 2400, and this will be 1600. Now the second part, the second rule, the moment you compute replacement ratio RR, you need to find out the minimum number, non-negative, which is positive. Okay, and that number is this, that number is this. This is called as leaving variable. This is called as the leaving variable. Okay, see what do you mean by this? Now when you proceed ahead, this S1 is going to leave from the table, and what is going to enter? Ladies and gentlemen, Y is going to enter the table. So whenever you write the next numbers over here, so S1 will go out, Y will enter. So Y, S2 and S3, this will be the flow. Okay, but wait, we'll do it afterwards. Now the moment you freeze this 900, now pay attention please. This corresponding to this Y, this 4 is there, no? But I'll use some other color. This 4 is there, no? This becomes your pivot element. Pay attention, this is very important. This becomes your pivot element. Pivot element. Now the rule is like this: if this solution is not optimal, listen to me, if this solution is not optimal, then we have to make it optimal. How will we make it optimal? I need to bring 1 over there. So this has to be 1, and the other elements which are non-pivot, this has to be 0 and 0. We need to convert that. So it has to look like this: 1, 0 and 0. But first we'll find out whether the solution is optimal or not. So how to find out in a simplex method whether the solution is optimal or not? Very simple. This NER is there, or Zj minus Cj. Everything should be positive. Everything should be positive. Sir, this is not optimal because there are negative numbers in that. Yes. So this means the solution is not optimal. If the solution is not optimal, to make it optimal, I've told you the rule. The rule is like this. The entering column, this is the entering column. So the pivot element, it needs to be turned into 1, and the rest elements 1 and 3 will be turned into 0 by equation. I'll tell you how it is. Simple. Okay. Now after this, what you need to do is pay attention now. I'll write here R1, R2 and R3. What is this? Normal row 1, row 2, row 3. So the point is, the moment you find out the pivot element, you need to divide by that number. So how do you do it? Sir, this will become 3 divided by 4. This will become 4 divided by 4. Pay attention. Huh? Obviously it's 1, I know that, but we'll write it, everything. This is the first sum. 3 divided by 4, 1 divided by 4, 0 divided by 4, and 0 divided by 4. Now you tell me one thing. 4 divided by 4 will become 1, 0 by 4 will become 0, and this will become 0. Okay. R2 and R3 will be as it is. How as it is? 2, 1, 3, 2, 1, 3. After that, what was there? 0, 1, 0, 0, 1, 0, and next 1, 3, 3, 1, 3, 3, and 0, 0, 1, 0, 0, 1. Now pay attention, please. So see, the first rule is very simple. What is that? To convert the pivot element into 1. We have already done it. We have to divide them by the same number. But for the next numbers, now see, this is already done. Ladies and gentlemen, see, this is already done. Now, we want the other two numbers, which is this and this, to be converted to 0. Now, you think and tell me, how can we change that into 0 and 0? So, I give you one small hint, okay? Pay attention. If I subtract R2 minus R1, if I do like this, So if I subtract R2 minus R1, that's rho 2 by minus rho 1, 1 minus 1 will become 0. Whenever you write this equation, so R2 minus R1, remember one thing, in this R1 will not change. So we are subtracting row 2, the entire row 2 by R1. So R2 digits are going to change, R1 will stay as it is because we have already got that number 0 over there. I hope we have got that. If we do this, this will become 0. Yes. Sir, what about R3? Because even R3, even in this we want 0 over here also. So very simple. You think now, can I write something like this? R3 minus 3 times R1. R3 minus 3 times R1 because I cannot change R2 over here. R2 is already changed, by the first equation. By the first subtraction, already changed. Now I need to change R3 also. So what I did, I'll multiply R1 by 3. It will become 3 over here and then 3 minus 3 will become 0. Yes. Then we will again check whether it is optimal or not. Did you get this, everybody? Okay. Now while we are doing this, what you need to do is, it's very simple. Okay, which is going out? S1 is going out. Y will come into picture. Y will come into picture. S2 will be here and S3 will be here. Okay. Now, chalo, we start doing this. Everybody, what is the Y number? So Y number is 4. Y number is 4. 4, 0 and 0. That's their coefficient. Okay. So please tell me one thing, whether R1 will change. So R1 is not going to change. R1 will remain as it is. The only two rows which are changing are R2 and R3. So what I'll do, 3 upon 4, 1, 3 upon 4, 1 upon 4, 0 and 0. Okay, number was 900 over here. Okay, now please pay attention. First subtraction, R2 minus R1. 2 minus 3 upon 4. I'll just do it here. 2 minus 3 upon 4. So 8 minus 3 is 5. This will become 5 upon 4. 5 upon 4. In the same fashion, you have to do the entire stuff. Okay, R2 minus R1. So 1 minus 1, 0. This is the most important part for us. That's why we are doing it. 0 we want over there. 3 minus 3 upon 4. 9 upon 4. Minus 1 upon 4. 1 and 0. This will become 1500. Simple. Now, last equation. R3 minus 3 times R1. So, you have to multiply the first row by 3. And next, you have to R3 minus 3 R1. So, you have to subtract entire R3. So, what you can do is, first I'll show you. So, 3 into 3 upon 4. This will become 9 upon 4. Right? Now, you have to subtract it. R3 is what? 1. This will become 1 minus 9 upon 4. It will become what? So, it will become minus 5 upon 4. Minus 5 upon 4. Do you get this? Minus 5 upon 4. Now this will become 0 because 1 into 3 is 3. Next you can solve it. 3 upon 4 minus 3 upon 4, 0, 1 and this will become 2100. Now after this, same thing is going to come. You have to compute Zj. Now see, Zj in this 0 will not come up because see, how to compute Zj? This into this, one second. This into this plus this into this plus this into, so 3 upon 4 into 4. Obviously this is going to become what? 3. Are you understanding this? 4, 3, 1, 0 and 0. Next is your NER. How to compute NER? Zj minus Cj. So 3 minus straight up. This is what? Where is Cj? 2. So 3 minus 2 is 1. 4 minus 4, this is 0. 3 minus 3 will become 0. 1 minus 0 will become 1. 0 minus this is 0 and 0. Okay, now you are good to go. Now all these numbers have become what? Positive. And now the solution is optimal. And now your answer is fine. You just write down over here as all numbers in Zj minus Cj row are non-negative, that means positive, are non-negative. Therefore, the solution is optimal. Solution is optimal. Okay. Now you tell me, What is your final answer, sir? Okay, so this we have understood mechanical and all that. What is the final answer? So, ladies and gentlemen, this is your final answer. So, see, these are the variables y, h2 and s3, and these are the corresponding figures. This, and this. Okay, how to do it? Pay attention, please. Pay attention. Now, can I write here over here? Y is equal to how much? 900. Next, S2. S2 is how much? 1500. And S3 is how much? 2100. Just I've just written on the figures over there. Okay. Now, the objective function maximize z is equal to, what was it? 2x plus 4y plus 3z plus 0s1, 0s2 plus 0s3. Just put the figures now. 2x plus 4 into 900 plus 3z plus 0s1 plus 0 into 1500 plus 0 into 2100. Okay, your answer will be this is 2 into 0, this is nothing. 900 into 4, 600 plus 3 into 0 plus 0. So your final answer will be 3600. This is your final answer. That's the end of simplex. Okay, now what you need to do is pay attention very properly. I'll repeat it again. So this was our question. First, what we did is we put it in a tabular format, a normal thing. First was a normal LPB question. This is what we did. Okay, this might be the end of the question. The point is 3 decision variables are there, and to solve this, we need to solve it by simplex. So that's when we started with the simplex thing. In simplex, the first thing we need to do is to formulate under simplex. How to formulate under simplex? Copy it on the same objective function, plus you need to add the variables. In this 3 is there. If 4 was there, then S1, S2, S3, and S4 would have come. Okay. Now, next, this is the main table, simplex table. I don't understand the main point of it. I'm explaining it again. See, in simplex table, the first point comes as CJ, that's the coefficient, and it's very simple. That's the objective function numbers over there, 2, 4, 3, 0, 0, 0. Next is CSV, current solution variable. You have to just write down the variable which you have used. And CB is the coefficient used in the CSV. That those are numbers 0. That every time it will become 0, 0, 0 only. Now, next you write down all the equations, the numbers x, y, z, s1, s2, and s3. B stands for right hand side of the equation, whatever number is there. And R stands for replacement ratio, which you need to do it at the end. Okay. Now, when you write down all the numbers over there, which is obviously your constrained numbers, after that, you will write the B part, the right hand side equation. Okay, pay attention. This, I'm talking about this. You will write down this. Do not compute RR. I'm telling you, वो आप बाद में आता है. सबसे पहले आपको क्या करना होता है? ZJ solve करना होता है. ZJ. So how to compute ZJ? Very simple. This number into this number into this number into this. Okay, plus करेंगे. The first thing is obviously going to come 0 only because these numbers will be 0. After that, the main part comes, and that is your NER. That is your net evaluation rule, which is to be computed by ZJ minus CJ. Now, this is very simple. You have CJ already here and ZJ already here. If this all comes positive, your life is very good. You don't need to do it once again. But that will not be the case because that is the simplex process. So one number will come negative. The moment you do these numbers, the rule says of simplex that you have to find the least number out of that. The least number will be this. Okay, anything which is there. The least number in this question is what? -4. This becomes your entering variable. So you don't have to look out for any other column. You only have to focus on the main, this column. The moment you do that, next step we will to compute what? Replacement ratio. Now, replacement ratio, you will divide this number by this by this, and this by this. You will get these 3 numbers. Out of that, you have to find out the minimum positive non-negative number. That is positive. Okay. And that is the leaving element. That is the leaving variable. So this suggests that S1 will leave from the table and this Y will enter it with this number over here, which we have already do it now. The moment we do this, this becomes this corresponding number out of which is this will become the pivot element. Now, as the rule says, this element needs to be turned into 1, which is very simple. Because we need to divide that entire row by this number only, and which automatically it will become what? 1. But the main point, the main process is the next two numbers which are there. That needs to be converted into what? 0 and 0. For that, you need to use your brains. How will I become? How will I put 0 over there? So the point is very simple. First, I divided by 4. I got 1 over here. The next two rows, I need to bring 0 over there. I need to think, how will I bring 0 over there? And so that you need to subtract the elements now. How do you subtract the elements? Very simple. So I needed to bring 0 over here and 0 over here. So first was very simple. R2 minus R1. The moment I do 1 minus 1, it will become 0 over here. But the third row, I need to bring 0 over here. So what I did is, I cannot change R1. What I did is, I cannot change R2. Sorry, R2 is already done. So what I did is, R3 minus 3 times R1. If I do this, this will change and I'll automatically bring what? 0 over here. One second. I'll bring 0 over here. Very simple. Now, after this, please don't forget, this also changes. This also changes because that S1 goes out, Y comes in, the corresponding number over here, which is there in the top CJ. And next, you have to follow this process till your solutions are optimal. That means you need to get all positive numbers over here. This is what you need to do, and this is your simplex process. Then you just need to put the figures in the equation. You will get the answer. Okay. Sure. The next lecture, you'll solve more sums. My only expectation is, please solve this question without looking. Practice, then do it 1 or twice. Just understand the process, and please watch the next lecture. In that, there will be next simplex questions. Okay, thanks.